In this video, we're going to talk about strings in Java. Now, before I even start, I want to make clear that there's a lot of things that we're sort of hand-waving over right now. There's a lot more when it comes to strings that you'll need to know to be an effective Java programmer, but those are things that we'll get to later. So for now, the goal of this is to give you just enough information about strings so that you're able to work with them doing some of the simple tasks we'll need earlier in the semester. So in this example, I've defined 4 different strings. String 1 is the string hello, and then string 2, I use the constructor with hello as the value. This is just to show you when you do this, string is a special type of object in Java. It allows you to initialize it with just a value, whereas with most objects, you would need to call new and then the class name to get the constructor called. But with strings, you can actually do this and it works fine. And so you'll notice, just to save some typing with these next 2 strings, that's what I did. One of the more important methods in the string class is length, and that returns the number of characters in that string. So let's run this and see. And you can see that the first two strings, my string 1 and 2, both have a length of 5 because they have 5 characters. And then string 1 has a length of 75, string 2 has a length of 49. So something that comes up a lot is trying to compare 2 strings. So the first example, we're going to compare strings with double equals. And if we say my string 1 is that equal to hello? And if so, we'll print that they're equal. Otherwise, we'll print that they're not equal. So if we run this, and that's probably what you were expecting, right? Hello is equal to hello. And let me add a blank line there. Let's use the equality operator to check my string 1 and my string 2. Those are both hello. So we would expect that it would say that they're equal. But it turns out they're not equal. Now, to be clear, if you're thinking this is odd because hello and hello are the same string, that's true. But keep in mind, when you're dealing with objects, the equality operator isn't checking their value, it's checking do they refer to the same object. So when it comes to strings, will that comparison work? The answer is it depends. And if the answer depends in programming, then you should treat the answer as no, that doesn't work. And what's going on here is it's storing this string somewhere in memory. And strings are what are called immutable. You can't actually change them. So if it knows it needs to have a string with hello in it, it'll store hello somewhere off in memory. When you use this same string literal here, and by string literal, I just mean a string that's in my code surrounded by double quotes. When I use this here, Java says, hey, I'm not going to waste memory storing another H, E, 2 L's, and an O. I'm going to just say, hey, these 2 objects both refer to the same string in memory. But when I use the constructor, I'm making a new object, and I'm populating that new object with the value hello. A couple things to keep in mind. Number 1, this is a little bit more efficient because there may be some optimizations it can do. Probably not a big deal, but in some cases it can be because you're not creating a new object unless you have to. And the second thing is if you do this, equality actually will work. But you want an equality operator that works all the time. So fortunately, Java does provide us with this. And that operation is the equals operation. So I can check if my string 1 equals my string 2, then we'll print the result. So if we do that, you'll notice we get hello is equal to hello, which is what we would expect. Another way to do this will be with the compare to method. And compare to, we'll talk about this later in the semester, but compare to will return negative if my string is less than my string 2, 0 if they're equal, and a positive number if my string 1 is greater than my string 2. For now, we'll just remember check to see if it's equal to 0. That means they're equal. So if we run this, notice that compare to equals 0, that actually gives us the right result too. So the moral of this story is when you're comparing strings, use equals or compare to if that's what you want. But avoid using the equality operator anytime you're comparing to objects. Now, Java provides a lot of string methods, and I encourage you to go through and look at the string class and see what's there. But you can also write your own. So in this case, I'm going to create a class called string205, and I'm going to write some methods here. These methods are actually going to rely on some of the character classes methods to help me write a string. Now, there's nothing special about these. These are really just arbitrary string methods I made up. But the point of this is to show you how to use the string and character classes. So the first example I'm going to show you is going to be an example of using the Character.isLetter method. And I'm going to write a function called justLetters. And it's going to take a string and it's going to return a string that has all the non-letters removed from the string. One thing to keep in mind is you can't actually change the string. So we're not going to be changing s at all. We're going to be creating a new string. And so if we wanted to use this to change a string, we would need to assign, let's say we had a string called string1. We would say string1 equals justLetters string1, and that would change string1 to where now it's referring to a string with just the letters from its original state. If we we want to have a string as a return value, and we'll initialize that to an empty string, and then we're going to return it at the end. We want to go through the entire string. So we'll say for I is equal to 0, I is less than, and we'll do the length of the string, and then we'll increment I. So this is going to run for however many characters are in the string. We're going to check to see if each character in the string is a letter. And the isLetter method does that. And the parameter here is going to be a character. So to get the right character, we need to say s and then char at I, and that gives us, this gives us the character of s at index II, and we pass that to this method, which will return true or false based on whether or not that character is a letter or not. Now, if it is a letter, we're going to append it to our return value. And now this method should work. Let's test that this works. So let's call this for original string 1, and let's do it for original string 2 as well. And we'll get the strings with just the letters working. And it looks like I have a typo. And so notice all the spaces are now empty. And let's go ahead and do string 3 here. So I'm just putting just some random stuff in this string just so that you can see that all of this will get removed. I'll go ahead and add string 3 to our length, and then we'll do an example here. That'll be a more interesting example, I think. And yeah, there you can see that it removes spaces, but it also will remove dashes and numbers. So this will just give us letters. And there's other values in that character class. I definitely recommend that you go through and see if there's any that you find that are interesting or useful, because they can definitely save you some time. So let me add a print line here to get a little more space. And there we go. All right, so the next function we're going to do is we're going to write a function that returns the string with the vowels removed. So we have a string return type, and just like before, let's start with an empty string. and that's what we'll return. There's nothing magical about the name ret, by the way. That's just something I use consistently as a return value because I'll always know what that is. Return, of course, I couldn't use since that's a keyword, so I just use ret. If you remember from our first example, we went through the characters of the string one by one using the char@at function. But there's actually an even easier way to do that. I can say for character C, that's in s.toCharacter or toChar array. And that's a really cool function because what that does is it converts the string to a character array. Now I can go through that array like any other array of characters instead of a string, right? I can treat it as an array. And in this case, I'm using what's called a for each loop. So this basically is the equivalent to saying for I equals 0, I is less than the length of this array, I plus plus, and then the first line would be C is equal to this array index II. We'll actually talk a lot about those in a few weeks, but I just wanted to show you this here so that you could get an idea of how you can use those to work with strings character by character. Now, we've already seen that there is an isLetter function. It would be nice if there was an isVowel function. However, when I do that, notice it says it's not available. Let's try this. Character is valid code point. Nope. So there's a bunch of things I can ask. Or I can check. There's all sorts of things, lowercase, uppercase, that sort of thing. But there's not one that says isVowel. So I'm a programmer. If I need a function, then I can write it myself. So let me define that here. So I'm going to write a function that takes a character, and then my default will be false. I'm going to switch on. I don't want to just switch on C. I want to make sure that it's consistent. So I'm going to convert it to lowercase. By converting the character to lowercase, I only have to compare it against the 5 lowercase vowels. I don't have to check if it's an uppercase or lowercase. It's not a huge difference. It wouldn't take a whole lot extra effort in this particular case, but this is just a good practice to get into so that you don't have to worry about handling all the possible capitalization cases. My first case is going to be case A. I don't know why it shifted there. And if you remember how a switch works, I can actually do this for each of these. And then if it's one of these cases, because remember, in a switch, if you don't put a break, the case falls through. So if it's A, it doesn't break, so it falls through to E. Then it picks up that, then it picks up I, O, and U. And if any of these happens, it changes return to true. And that should be sufficient. So let's give this a try. It looks like our code wants to work. So I'll remove the vowels, and then I'll do the same thing for the other 2 strings. And when we run this, we get nothing. So that's not good. If it is a vowel, then we'll add that character to the return string. Now, you'll notice the way we did our loop here, this does basically the same thing that this loop does, except that there's a different comparison. But you'll notice this code is a little bit cleaner. So again, sometimes it pays to use different techniques in order to simplify your code. And so here, converting it to a char array, using a for each loop, and then writing our own method to determine something really cleaned up everything. I didn't have to keep doing this char@, and so forth. Okay, so now we expect it to work, and you can see that it does. The last example we're going to do is we're going to write a method. And I guess we want to make these public. They're in the same package, so it doesn't really matter. But if you were going to import this outside, all these could be. Now, You may ask, why did we make this public? Because we're only using it internally. Well, it's still a good function, and we're more than happy to provide that. There's no data that's being updated here that we need to worry about, so I think that's a sufficient way to do that. So our last method, we're going to print the words in a string one by one. When we say word, that has can have a lot of different meanings. We're going to say that a word is separated by a space in the string. So whenever we have a space, we're going to call that a word. So we're going to have a method, and it's going to return void because there's nothing really to return. We're just going to print the words individually. It's going to take a string as a parameter, and I'm going to make a string array out of, and it's going to be called words, and I'm going to make that out of the string s, but I'm going to call the split function, and I'm going to say split anytime you see a space. So this is going to return a string array that is all the pieces of s split up wherever there's a space in s. And if that doesn't make sense yet, when you see the example, I think it'll be a little more clear. I'm going to have a for loop. So I will be less than, where's that linked? And we'll increment II each time. And of course, we could have used a for each loop if we wanted, but we didn't. Now I have to decide how I want to display this. And what I'll do is I'm going to print just the word, but I'm going to put brackets around it. So we'll say a bracket, and then actually just to show that we're doing something kind of interesting here, we'll put the order of the word in parentheses, so II, and then we'll close the parentheses. We'll print the string that's at words II. Remember, that's our array of all the words. And then we'll have our closing bracket, and we'll put a space at the end. And then once we're done with that loop, we'll put a print line. So we're missing a plus here, it looks like. And we have a typo there. So the way we're going to call this function, first off, let's print. We'll print that these are the individual words, but we're not going to call this in this line because it's a separate function. We'll call string one, or actually we'll have to call it string 205, individual words, string one. And did I not save this? Why is it not seeing that? So public individual words, it's saved. I did make this static. And again, this is, since we're not instantiating an object, to call a method in this class, we have to make sure that it's a static method. So that should fix that. Okay, and let's do the same for the other other two strings, I should say. And string 3, string 2. And when we run this, you'll see that it prints the individual words. Let's change this to just a print. And so you can see it prints the individual words. Here, notice we had this weird shape at the beginning, so that's the first word. Again, it's not really doing words. I could say, hey, let's split these up. And if I could actually look at that string here and say, hey, if this is actually a word, if I had some way of checking that, I could check to say, hey, is everything a letter? Or, is maybe I could have a dictionary I could compare it against or something. I could do that. But this is just sufficient for now. The big things that I wanted to make sure you saw was you can use the split method, which is really powerful to split up your string in different ways. And you'll definitely find that helpful, I think. So this is a not quite as quick as I would have liked introduction to strings in Java, but hopefully it's helpful for you. There's definitely some things with strings that can create a gotcha for you, but hopefully this will help you avoid some of those. And we'll definitely talk more about strings later in the semester.